Okay, so I want to show you guys about matrices today. There is no daily point. Yeah, but um, let's see. So a matrix in of itself is just an array of numbers. Okay, so when it says what's a matrix, it's just an array of numbers. Right? It allows us to organize numbers into a rectangular form. Okay? So there's nothing really special about a matrix in and of itself. Okay? But it's just a way to organize numbers. When we look at a matrix, though, it is divided up into rows and columns. And so the rows are the horizontal portions. Okay? And we always talk about the rows of the matrix first, and then the columns are, you think about columns on a building, they're the vertical part of the matrix. So this matrix has 2 rows and 2 columns, and what we'd call that would be a 2 by 2 matrix. So we just use that little X there to stand for the word by, but you say that it's a 2 by 2 matrix. Okay? Just as another example, I'm just going to make up another one. The numbers here do not matter at all. Okay? I'm going to make what will be a 3 by 5 matrix. Just using random numbers. Okay? So this is a 3 by 5 matrix. It's 3 rows. And there's 5 columns. So the dimensions of a matrix are always rows first, columns second. When we, Thursday, look at how to add matrices, how to multiply matrices, things like that, you have to know how big the matrix is first. When we do something later on with this calculator I'm going to show you guys, you have to know how big the matrix is first. So, but really nothing too crazy about it. Just number of rows by number of columns. That's it. Okay. An augmented matrix. So it's just a type of matrix, obviously. But this right here is an augmented matrix. So the augmentation is just this vertical line. Okay? So the difference between an augmented matrix and a matrix is just that the augmented matrix is going to have a vertical line running through it. Okay? What we do with augmented matrices is we take systems of equations and we rewrite them as augmented matrices. So I'm going to rewrite this system of equations as an augmented matrix. So I'm just going to put each equation into a row of the matrix. And as I do that, I'm going to pull the variables off of it. It's only the coefficients. So only the coefficients. So the 5, and then the -1, and then that vertical line is going to go there, and then the 21. So that's the first equation becomes the first row of the matrix. And then the second equation becomes the second row of the matrix. Again, you only pull the coefficients off. So 2, 3, and then -12. So essentially the augmentation bar is just kind of separating the coefficients from the constants. All right, what's attached to the variables versus what's not attached to the variable. Okay? Coefficient bars, or the augmentation bar, is kind of acting like the equal sign. Okay, so that's what the that vertical line is the augmentation, but there's anything more special about it. And when you augment something, you're just adding a little bit to it. You're just adding this vertical line to it. Again, it's just acting like the equal sign. So this is how we're going to use matrices to help us. So we're going to take a system of equations, we're going to write it as a matrix, we're going to use some what are called operations on that matrix to then solve that system of equations. We were just solving systems of equations yesterday. We're going to be solving them in a different way today. What is unfortunate is that with the size of the systems that we're solving, you're not really going to see the benefit of doing it with a matrix. It's not really going to be any easier doing it this way than the way we've been doing it. This method comes into be handy when you start looking at very large systems of equations. Okay? With my college algebra students, we were looking at solving systems of 3 equations with 3 variables. And those are problems that will take up at least half a page of paper doing it by hand. Okay? So then we were talking about how to solve a system like this with matrices. Okay? It's still kind of cumbersome with a matrix. But where you should really start to get gets really handy is if you had to have 4 equations with 4 variables, or 5 equations with 5 variables, or 6 equations with 6 variables. Matrices get much simpler to deal with at those sizes than just doing it by like with elimination and substitution. Well, we're not going to get into that stuff. Right? It's way above where we are. And even with my college algebra students, I wouldn't get into that with them. You really would have to be taking like a matrix class in college in order to deal with matrices that large. So we're only going to be kind of touching the surface of what matrices are, just kind of introducing this stuff to you guys. There's a little bit of matrix stuff on the ACT, but not much. Okay? They are very, very useful, but it's like a very specific application, a lot of like business applications to this. If you can imagine that you're like a company that makes things, right? You make multiple products. You make pencils, you make pens, you make calculators, you make notepads, right? And so that means you're bringing in all sorts of supplies so you can make all these things, and then you're shipping stuff out. And all of a sudden there's a rush on pencils. You're like, oh, we need to make some more pencils. Well, you can't just make more pencils without having something else happen, because you can't just have more time, you can't just have more supplies, you can't just have more people, you can't just have more machines. In order to shift production to something else, you'd have to take away production from something else. So every little change that you do in your company is going to cause like ripples of effects through everything else. So keeping track of all that information, what's coming in, what's going out, what's changing, like how much time am I doing this versus that, if we can set that up, that array of information in a matrix, and keep track of it much better that way. Okay, obviously computers do that now, but somebody has to program the computer programs that keep track of all that stuff. The people that do that programming need to understand matrices. Okay? That's one application. But basically a matrix is just going to allow you to keep track of lots of data, lots of inputs, lots of outputs, all at the same time. Okay? And we're just not going to get that big. Okay? So they do have uses, just it's kind of a set use. Lots of data that you need to be keeping track of. A matrix would be really helpful. Okay? So we're going to start by just looking at simple systems and rewriting them as an augmented matrix. Okay? We're going to have 2 equations, so we're going to need just make sure you have enough room to write 2 lines. Each equation gets its own row, and all you need are the coefficients. It's kind of like when we did synthetic division. Right? When we did synthetic division, we just pulled all the coefficients off and we wrote them across the top of that half box. Well, I look at that x, and I see that as a 1x. And I look at that y, it's a 1y. Then I have my augmentation bar, and there's an 8 over there. So there's the first equation written in the matrix. So how would we write the second equation in the matrix? All right. 1, -1, 4. Right, Brian? Okay. Go on, look over at number 2. What's different about number 2 than the other 2 that we've done so far? Okay. So Brian's saying there's a space there. What's missing? What should be that space? What should be there? A y, right? There should be a y there, right? We don't have a y, so nothing is 0, right? So there should be 3x and then plus some number of y's equals 24, but there is no y, so yeah, that y that's not there just becomes a 0. So again, like synthetic division, when we had something that was missing, we had to put in a filler, right? There had to be something filling that gap. We couldn't just leave it blank. Okay, we couldn't just skip over it. So There are no y's, so we put 0 y's written down. Kaylin, what about that last equation? 1, 2, 1, 2, 0. Right? Okay. So rewriting a system of equations into a matrix. Right? Nothing too crazy going on there. Okay. This next part's just going backwards. So what if we have the augmented matrix? How do we rewrite it as a system of equations? So what we need to just agree upon is that there has to be an established order to our matrix. I can't just say, like right now that one right there represents 1x, and that one right there also represents 1x, and that one represents 1y, and that one represents negative 1y's. Okay, these are my x's, these are my y's. We have to just say that we're always going to go in alphabetical order. We just have to establish that and just be okay with that, no matter what the letters are. If it's A's and B's, if it's R's and S's, if it's X's and Y's, we should always say the first column's the first one in the alphabet, the second column's always the next one in the alphabet. Okay? And if you decided to mix those up, that could definitely be confusing to somebody else that came along. Just like if all of a sudden you said, well, today I want my y-axis to be this one and this one to be my x-axis. It's going to be confusing. Okay? So it's always going to be the first letter and the second letter, and on the other side of the bar is the answers. So as I look at this and just having to assume that those are x's because we don't have any context here, and I just have to assume that those are y's, or they're a's and they're b's. But these two go together and those two go together as far as the letter they get. But we'll just call that the x column. We'll just call that the y column. Okay. So as I look at that first row, I have 1x, so x, I have 4 y's, positive 4 y's, so plus 4 y's, and it equals 1. So I can go backwards, right? So Mason, what would the next row be as the equation?
3x plus 2y equals negative 12.
All right, 3x plus 2y equals negative 12. No, we don't put anything on the equation. Oh, I see, the little curly brace.
Yeah,
No, we don't need to. Yeah, Mason was asking if we need to do the little curly brace thing. No, I'm not worried about that. You can do it if you want. It's not going to hurt anything. Jordan, what about on number 4? What's the top equation going to be? Right, x plus 3y equals 5. Aiden, what about the last one? 2x minus what? All right. Okay. So 2x minus 3y equals negative. So going back and forth between the two forms really should be pretty simple. Okay. Don't turn over yet. Is there anything about the dimensions or about going between the equation form to matrix form you guys want to check in on real quick? So generally, what we're going to be doing is going from the system to the matrix. So, that's what we're going to be given is the system. We're going to solve the matrix. We don't do this very often. We don't go this way very often. About the only time you do that is at the very end of the problem. Our goal is going to be to get the problems to look like this. This is called reduced row echelon form. So we're going to talk about how do we get the matrix that looks like this. We're going to do what are called row operations on it and say how do we get it from this to this so that the top left number is a 1, the bottom left number is a 0, top right number is 0, bottom right numbers is 1. And then these numbers that are over here on the other side of the bar are just whatever they are. We don't mess around with those. They just they kind of just follow along with what we're doing. We mess around with these because those are where the variables are. So how do we take it from this to this? And why would I want it be from this to this? Why is this any better? Well, when I look at this matrix, and I look at that top row, what it says is there's one x, no y's, and then some number. So that means that that 1x equals whatever that number is. So now I know what x is. And in pretty similar way, when I look at that bottom row, it says there's no x's, but there's one y equal to some number. So y equals some number. So now we know what y is. Okay? So if we can get it into this form, then we have the answer to the system. Okay? That's called reduced row echelon form. We're also going to talk very briefly about how to do it with a three-variable, three-system equation, or three-equation system. Okay? But we're going to use a calculator to do this. But for that, reduced row echelon form looks like this. So what we're seeing there is there's a diagonal of ones, and everything else is zeros. So how we expand that is that what we have is our x's here, our y's here, and then our z's will be our third variable usually. So I have one x, no y's, no z's equals some number, so we just know what x is, right? X would be some number. No x's, one y, and then no z's, so I have one y equals some number. And then the last row would say, no x's, no y's, but have one z equals some number. So if we can get a bigger matrix into that form, then we would know the value of each variable there. So that's reduced row echelon form for a three-variable, three-equation system, which would look like that. Right, so we'll talk about how to use a calculator to do that. But first I want to show you how to do it by hand on smaller ones. Okay, so this is going to be our goal, that we're going to try to take the problems from this form to this form. And that's what we're going to go and learn now. Okay, I really need you guys to just like keep your mind just like completely open. Okay, it's going to seem really confusing at first, as well it should, because you guys have never done anything like this. But if you go back and think about how we did, very first time we did synthetic division, I said, well, just write down the numbers and we'll change the sign on this number. And then, well, now we're going to start multiplying and adding a whole bunch. Right? And we did that the first time. You're like, what is this mess? But then you see that it works and you start practicing. And you're like, oh, this is actually really easy. Okay? So it's going to be like, it's just going to be a hot mess for a minute. I just really need you guys to keep your mind open. Make sure you're asking questions if something's not making sense. Okay? So I can fill in what's going on. But the first time we do it, you're going to be like, ah. Okay? Second time we're going to do it, you're probably still going to be like, ah. Okay. You're going to need to practice a little bit on your own. We'll talk about it some more on Thursday just to make the ahs go, ah. Like that. That's good. So, okay. But just keep your mind open. Okay. Ask questions when they come up. Okay. So, we're going to get into reduced row echelon form, which is RREF for short, because we don't want to say reduced row echelon form over and over again. If you didn't write this down earlier, definitely would. What it looks like. 1, 0, 0, 1, augment bar, whatever number. Okay? We get to play around over here. These numbers over here will just follow along with whatever we do, and we don't control them. Okay? So what reduced row echelon form looks like for any size matrix is there's a diagonal of diagonal of ones, and then everything else is a zero. No matter what size the matrix is, it's always a diagonal of ones, everything else is zero. There is typically a easiest path through these problems. So just like we were talking about yesterday, like, which one would be easier to do, right? Always trying to think about that. Typically the easiest thing to do when you do a problem like this is to start in that top left corner, say, how can I get that to be a 1? And then move down to the bottom left, say, how can I get that to be a 0? Then move across, and then move back up. Okay? So this is the path I'm going to follow through the problem, trying to change things along the way to meet this. This is kind of our map. This is our key. This is what we want the problem to look like when we're done. Okay? This is our goal. Okay? So So we have this system, which we've already turned into a matrix on the other side of the paper. Okay, so I'm not going to dawdle over that. That was 1, 1, 8, 1, negative 1, 4. Okay, we already did that one. We need to take this stuff right here and mess with it to make it look like this. Okay? And as we do that, these numbers over here will change and we'll just end up with what we end up with. Okay? So what you guys need to remember is that that's not just a 1 and a 1 and a 1 and a negative 1. That's a 1x, and that's a 1y, and that's a 1x, and that's a negative 1y. They represent something. We pulled the variables off to make the math faster. We got to remember they actually represent something. Okay? If you lose track of that, you're going to try to do things you can't do. Okay? And we're solving a system of equations, and we already know how to solve systems. We already have tools for solving systems of equations. So we're going to look at something similar here. If we wanted to do the elimination method here, we wanted to eliminate those x's specifically. Oh, sorry, let me back up. So we start up here in the left corner, right? We want that to be a 1. We look and say, oh, it's already a 1. Sweet, step 1's dead. Okay? So then we say, okay, the next thing I'm supposed to go do is look at the bottom left corner. I want it to be a 0, but it's a 1. How do I get a 0? Okay? So if we were thinking about the system of equations like we were yesterday and saying, hey, how can I get those x's to cancel? Because I want a 0, canceling 0. How would I get those x's to cancel? What would we have done yesterday to make those cancel? We want 1 to be negative, right? If I have a positive 1 and a negative 1 and I added them, then they would cancel, just like we saw yesterday. So that's what we're going to do here. We're going to say, well, what if that was a negative 1 and I added it to that? It would make that a 0. Okay? So we're going to use this little bit of notation, and this is going to be really important for you guys to communicate what you're up to. Okay? You don't need to write these right here, but if you want to, you can. This is going to be called row 1. This is going to be called row 2. So we just say that either. Let's look at row 1. Let's look at row 2. Okay? So we want one of those 1's to be negative. We want one of that 1x or that 1x to be negative x instead of positive x. It doesn't really matter which one you do. Generally, people will look at the one that they're not trying to change. Like, I'm trying to change this one. So I'll say, well, I'm going to make that one a negative 1. But mathematically, it doesn't really matter. So I'm going to say negative 1 times row 1 plus row 2. So I want you guys writing this here to let me know, to let you know what you're doing. What's the plan? What's the next step? Okay, because if I have to come along and look at your work and you haven't told me what you're up to, I'm going to have no idea how to check through and look for mistakes. Okay, so you need to write a plan. I want this to become a 0, so I'm going to add negative 1 to it. I don't have a negative 1 though, so I'm going to make a negative 1. I'll multiply this row by negative 1. I'm going to add it to that row. So here's your open mind. We're not actually changing row 1. We're just using it, but we're not actually changing it. All we're trying to do is change row 2 because we want that to stay a 1. And if I actually multiplied it by negative 1, it would not be a 1 anymore. All I'm trying to do is change row 2. So what I'm going to do, what I really want you guys to do, once you know what your plan is, we're trying to change row 2, you immediately go write rows you're not changing. Okay? We're not trying to change row 1, so you immediately go and write it so you don't accidentally change it. Okay? So this is kind of weird part. We can say that we're going to multiply row 1 by negative 1 and add it to this, but we don't actually have to multiply it by negative 1. Okay? We'll do it, but we're not actually going to do it. Sounds weird. Okay? So we really want that to stay a 1, so we don't actually want to do it. What we're going to do is kind of pretend that we do it for a second. So I'm going to take negative 1 times row 1. I'm going to put it right there. I would really suggest you guys don't circle these things. I'm doing it so you can see what we're up to. But if you go through and you circle things or mark things up, you end up making a mistake, and you have to like try to go back and look through all your marks, it's going to be really tough. Okay, so I'm just highlighting that so we can see what I'm about to do. I'm taking each of those numbers there and multiplying it by -1. That's what that says. I'm going to write that right here. So you guys should do this because you're not going to be able to keep track of all those numbers. So this is row 1 times -1 right here. Okay, notice I did not put that over here because I didn't actually change row 1. But now I want to add it to row 2. So now I need to go and do these additions. So 1 plus -1 is 0, and -1 plus -1 is -2, and 4 plus -8 is -4. So I got the 0 that I wanted. I didn't actually have to mess up the 1 that I had that I also wanted. Okay? So we're allowed to do that. I can take this row times -1 and add it to this. I don't actually have to change that row. Okay? What I'm trying to do is change that one entry. That's the part you kind of got to let go of a little bit. It's okay to do that. But here's where we want to be, right? 1, 0, 1, 0. Next thing I want, follow my path. I want that bottom corner to be a 1. Well, it's a -2. Okay. So we talked about how this was like a system of equations and how we could cancel those variables out by adding them together if they were opposites. And so we did that. Remember, this is an equation. How can I turn this into a 1? Divided by -2, right, Hayden? Because remember what that stands for. This is -2y equals -4. Our very next step would be to divide by -2, right? So y equals 2. Well, what's right there in front of the 1? Sorry, a y, the 1. Well, so I can turn that -2 into a 1 by just dividing it away. Now, why that's okay to do is because if I do it to one part of the equation, I have to do it to the whole equation. So -2 divided by -2 is 1. -4 divided by -2 is 2. And 0x's divided by -2 is still 0. So I'm not messing with that 0 that I wanted earlier. Right? I really want to make sure that's a 0. Dividing it by -2 is not going to change it. So we're protecting it. Okay? So to get a 0, usually you're doing some sort of adding opposites type thing. To get 1s, usually you're doing just some sort of division. Okay? But we're just using what we know about equations to make sense of it. So we just say row 2 divided by -2. That's my next step. And I am writing these in particular places, like I'm trying to change something about row 2, so I'm writing it next to row 2. I'm trying to change something about row 2, so I'm writing it next to row 2. And that's something that I do for myself, and it's not like a standard thing. So because I'm changing row 2, I'm going to immediately go and write down row 1. And the first year that I taught my college algebra students this, I hadn't really caught on to that little tip yet, and it just leads to putting numbers in the wrong spots quite often, or messing with things you're not supposed to mess with quite often if you don't immediately go and write down the thing you're not messing with first. Then go back and mess with stuff. Do this math that we just said we wanted to do. So 0 divided by -2, 0. -2 divided by -2, 1. -4 divided by -2, 2. Then you always go back up and say, hey, where am I on my map? Where am I? My goal, 1, 0, 1, 1, 0, 1. Next thing we want is a 0. So think about how we got a 0 the first time. We used x's to cancel x's. Here we can use y's to cancel y's. Right? I have 1y here, I have 1y here. Well, if that was a -1y, then I could use it to cancel that 1y. we're essentially going to do the same step that we did here. We're going to take -1 times that, and then we're going to add it to that. But I'm changing row 1. I'm trying to change that, so I'm going to write it next to row 1. -1 times row 2 plus row 1. But because I'm not trying to change row 2, I'm immediately going to go and write row 2 down. So 0, 1, 2, so I don't accidentally mess it up. And then I need to find a space to do this math right here so I don't lose track of things. So generally I like to do that right above or right below the matrix. And generally I like to do it right next to the thing I'm going to add it to. I want to add it to row 1, so I'm going to put the numbers next to row 1. I got to make sure I'm using the right numbers. Like I'm supposed to be doing -1 times row 2. So make sure I write each of those numbers times -1. 0 times -1, 0. 1 times -1, -1. 2 times -1, it's -2. And then I'm adding. 0 and 1 give me 1. -1 and 1 give me 0. There's the 0 we wanted. And then -2 and 8 give me 6. And we're done. I know I'm done because it matches this. 1, 0 is 1, 0. 0, 1, 0. So the last step here is just interpreting what we have, right? Making sense of this matrix back as equations. That top row says 1x, no y's, is equal to 6. 1x, no y's, is equal to 6. X equals 6. Bottom row says no x's, 1y, is equal to 2. So y equals 2. So we know our point, 6, 2. We can go and see that works pretty quickly. 6 plus 2 is 8. Yep. 6 minus 2 is 4. Yep. So we can check them very quickly. You guys aren't going to have big, ugly equations or anything like that, so the check should be pretty obvious just to do visually. Make sure you actually did it right. Okay? Obviously, we're going to do another one here together. Is there something that you guys want me to highlight as I go through it? Let's put it back in, right? X is 6, y is 2, so 6 plus 2 is 8, 6 minus 2 is 4. Just visually check it really quick. Anything like for sure you want me to make sure I'm really talking through more clearly? This is like problem solving at its most. Like you have to make lots of decisions here, guys, about what's the next thing I should be doing. I'm giving you kind of a path to follow, but that's just an order to do things. It's not telling you what to do. Okay. Let's try it again then. Yeah, we already wrote this as a matrix earlier. That was 3, 0, bar 24, 1, 2, bar 0. I always tell you guys to go back and look at that key and say, where am I? Where do I want to be? So looking at that top left number, I want it to be a 1. I've got a 3. Remember what it stands for. It's 3 x's equals 24. Because there's a 0 there, I can just do whatever I want to that number to make it a 1. We just divide it by 3. Okay? So I'm going to turn that 3 into a 1 just by dividing by 3 because it's not going to change that 0. If that had not been a 0, division by 3 might not have worked. Okay? So I'm just taking row 1 and dividing it by 3. but I'm not changing row 2, so I'm going to bring that down first. 1, 2, 0, so I don't accidentally mess with it. Hey, oh, cool. So then I go and do that math now. Oop, not erase it. So 3 divided by 3, 1, 0 divided by 3, 0, and 24 divided by 3 is 8. So looking where I am, looking where I want to be, got that 1 now. Follow that arrow down, say let's get that next thing to be a 0. I want this to be a 0. So I think this is the third time we've seen this. You guys, again, they're pretty small numbers right now. Okay. If I want a 1 to cancel a 1, I need a negative 1 to cancel a 1. Right? This is 1x and 1x. So we can't just subtract 1. Right? X minus 1 isn't 0. I can subtract an x, or I can add a negative x. Right? So we're going to do essentially that same thing here. Right? We're going to take row 1 times negative 1 and add it to row 2. Okay? So Aiden brought up a really good point, right? We can't just take 1 away, because that's not a 1. That's a 1x. Right? It stands for something. So I can't take 1x minus 1 and get 0. I need to take an x minus an x, or x plus a negative x to get 0. So I'm going to take negative 1 times row 1, and I'm going to add it to row 2. Trying to change row 2, so I'm going to bring row 1 over immediately. Then I'll go back and worry about row 2. Okay? I found that so helpful to do that. Bring over the stuff you're not trying to change first, then go back and change things. I want to add some stuff to row 2, so I'm just making a little space here for myself down here by row 2. Make sure I multiply these numbers here by negative 1. So negative 1, 0, negative 8. Then I want to add these numbers together. Zero, 2, negative 8. So where are we? Where do we want to be? Got a 1, a 0, 1, a 0. Next thing I want to look at is that bottom right corner. I want that to be a 1. So Aiden's saying we should just divide by 2. So again, most of the time when you want to go from a number to a 1, most often you're just going to do is some division. Not every time, but most often you're just going to divide by something. Remember, that's 0x's, 2y's equals negative 8. So if 2y's equals negative 8, we should know how much 1y is. Yep, divide by 2 will be our next step. So we're going to take row 2 divided by 2. Since I'm not changing row 1, I'm going to write row 1 down immediately. 1, 0, 8. Then I'll go back and worry about that math. Make sure I take each of those numbers divided by 2. 0, 1, negative 4. And luckily that top right one's already a 0, so we don't have anything else to do. We have 1, 0, 1, 0, 1, 0, 1, 0. So we're done. We just need to write our answer and then check our answer. That first row tells us that 1x is equal to 8. And the second row that tells us that 1y is equal to negative 4. So we should be looking at 8 and negative 4 as our answer. So checking it really quick. So 3 times x, so 3 times 8 is 24. 8 plus 2 times negative 4, so 8 plus negative 8 is 0. So they both work. So on your guys' worksheet, you guys do have some problems like that to try. I mean, you really just do need to start trying, seeing what's making sense, what's not. There's really no other way to get around it besides just digging in a little bit and seeing what you can do, seeing where you're getting stuck. If you just stare at it and be like, I don't know what to do, then you're not going to get anywhere. You got to have some place to start. Okay? Again, follow the key. Make sure you're paying attention to like the order that's generally wanted to do, what you're supposed to end up, where you are, where you want to be. Again, generally when you want zeros, you're going to be adding opposites. So find a way to make opposites. Generally when you want ones, you're just going to be dividing by some number. Okay? It's not that way every time, but those are good general ways. All right, so now you guys are going to need that link that's in your Google class. I'm going to show you how to do this with a calculator. Okay, it pretty much does all the work for you. I'll show you how it works. All right? But in order to put it in the calculator, you have to write it as a matrix first, and you have to know how big the matrix is. Okay, so your first step needs to be write this as a matrix. Should be pretty easy. So we get 3, 3, augment bar 3, and then 4, 2, augment bar 8/3, just write it as a fraction. And we also have to know how big our matrix is. Remember, that's rows. There's 2 rows by columns. 1, 2, 3, so that's a 2 by 3. You're going to hit that link that's in your Google class. So free, so there's ads. So I just gotta walk past those. Okay. So where you guys need to be looking here is here. It says the size of the matrix. The default size is 2 by 3, so you won't need to change it right now. But when you need to change it later, you just hit the drop-down menus. Okay. And then you just type in the entries there in the rows. So just make sure you get the right numbers typed in. Of course, if you type in the wrong number, it's going to screw everything up. That was 3, 3, 3. What was the next one? 4, 2, and the 8/3. So then just do 8 divided by 3. There, okay, just 8/3 like that. And you see the little blue parallelogram down there. It says calculate, so just click calculate. And it just takes a couple seconds to do it, but you'll just need to scroll down. And it goes through and shows you what it's doing. So it shows you all the steps. And there's the answer matrix. So 1, 0, 1/3, 0, 1, 2/3. So that's what I'm going to write down. 1, 0, 1/3, 0, 1, 2/3. Don't worry about the decimal stuff. So 1, 0, 1/3. 0, 1, 2/3. So just like before, you guys just interpret that, and you're done. So x equals 1/3, y equals 2/3. 1/3, 2/3 would be the location of that point. We're going to do that again with the bigger one. Okay. So you just need to write this bigger matrix. 1, -4, 2, augment bar, -9, 3, 1, 1, 4, -2, 3, -3, 7. Double, triple check each of those entries. Make sure you wrote the right thing. Then you're going to count your rows. So 1, 2, 3. Count your columns. 1, 2, 3, 4. This is a 3 by 4 matrix. So go back to the calculator. So you need to change the size. Make sure you always put the number of rows first. 3, 4. Okay, so to adjust everything for you, and you guys need to type it in. I can't see it anymore. What was our first row? Said 1, 4, 2, and then what? Okay. What was the second row? And then what? 4.
Oh, yeah.
Thanks, Sam. Yeah, so double check your typing. It's so easy to mistype something. Yeah. If that's all you have to worry about is your typing, then make sure your typing's good. And you're not doing any math, so make sure your typing's good. Again, it shows you all the steps it's doing. This tends to do things in a lot more complex way than I would. It deals with, start seeing a lot of fractions in there. I would look for ways of avoiding those fractions. Then it gets you here, right? So we see the reduced row echelon form. So see the 1, 1, 1 that's going down, right? It doesn't draw the bar, okay? So 1, 1, 1. So then the answers are over there on that far right column, 1, 2, -1. So 1, 0, 0, 0, 1, 0, 0, 0, 1, and 1, 2, -1. So that means x equals 1, y equals 2, and z equals -1. So there would be our ordered triple. That's what that's called, is an ordered triple. So I have an ordered pair. It's an ordered triple. What it does is represents a point in 3-dimensional space. You have your x values that would go side to side on the plane. You have your y values that go up and down the plane. But then that z value would be down 1 out of the plane, like below the plane. So it'd be a point in 3-dimensional space. Okay? But give those problems a shot that are like the solving by hand. I know it's not easy, especially the first time you do it. Okay? But it does get a lot easier. You got to practice in order to make it easier. Okay? And you can always, check your answers, either old-fashioned way of checking or checking with the calculator. Okay? But I'll have time tomorrow if you guys want to come in for help.